I hope that works. I don't know if it does. Oops. I may have to be live here. Okay. Okay. Focus back. So I said I don't like it when they say find the fourth term or find the second term, right? Because officially, it doesn't matter if I do. Oh, I got to turn this on. Officially, it doesn't matter if I do x plus 2 to the fifth or if I do 2 plus x to the fifth. Y'all follow what I'm saying? Right? So the fourth term of this one is different than the fourth term of this one. And so typically I don't think they say find the fourth term. I think they'll say find the coefficient for the x to the third or something like that. Because x to the third won't matter if you put it here or here. Y'all follow? Y'all kind of good? So anyway, just kind of work. It doesn't matter how you put those. Now, if it's x minus 2, that kind because you got to do negative 2 plus x, but you can still switch those too also. Okay, because it's inside the parentheses, and inside the parentheses, you're trying to add that first, right? So inside the parentheses, it doesn't really matter if you do x plus 2 or 2 plus x because you get the same thing. Then when you take it to the fifth power, you got to multiply it all the way out. Anyway, that's something that just a little extra stuff you get. Hit me.
The binomial packet was a single page.
It was a single page. Yep. It was just that single page. And we did the every other odd as all I told you to do. I thought that was enough. It was Pascal's triangle, by the way. She's not listening. Somebody in this class, I don't know who, saved it as pyramid. Made me laugh. But it's okay. It's not a pyramid, it's Pascal's triangle. Okay. We were going over this worksheet. So, yada, yada, yada. I'll post this if you guys really want to check, but if there's something that you really want me to make sure that I go over. Was there another 11? Jacob, was there another number 11 you wanted me to hit? Or Jonah, thank you. I know I had 2 of them. Oh, and then it started like multiple choices, right? When you see these multiple choices, those are like you're going to see multiple choice and you're going to see free response, right? As we get closer to the exam, which is next Wednesday, right? So today we're going to finish up the chapter. Today we're finishing the chapter. Friday's a B, Monday's review, test Wednesday. But I'm going to give you everything today. And we're going to do some stuff in class on Monday, but you won't have a whole lot of time to do the reviews that I'm going to give you in class. Okay, just kind of, we're going to review in class on Monday also, but I'm just giving you a bunch of other stuff. And I'll let you know more what to expect as, if you want to call it the free response part. Okay, because I told you, if I hadn't, on your AP test, we know the questions. They tell us what the questions are. And so we know what they're going to ask free response wise. We don't know what the numbers are. We don't know the context of it, but we know about what it's going to take, what you're going to have to do. Different than any other AP class. Multiple choice, multiple choice, multiple choice. And then multiple choice, right? Okay. Everybody okay with transformations? Anything else, right? The only thing I think, talking to my constituents down the hallway there, the biggest thing was the horizontal I don't know how I said it. Dilation. I almost said compression. Horizontal dilation. Maybe the reflection for horizontal and horizontal reflections over the Y. So when students mess up, that's what they meant. I messed up the other day. I think I said it backwards, or I just always have to think, okay, all the positive x's are now negative x's, so that has to be over the y. If it's the positive y's are now negative y's and vice versa, then it's over the x. Okay, so I just think about it that way every time. rather than me have it memorized. I think this class is better off knowing, just thinking through it as opposed to memorizing it. Okay. Everybody happy, happy, joy, 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 joy? Today's more of a process of how to do things, not necessarily what you're doing, although what you're doing is important. This is 100% calculator stuff. Okay, 100% calculator stuff. So we got to get familiar with these calculators. Okay, and what we're going to do today with these calculators, we're going to do 6 more times. So it's very important that you understand what you're doing with these calculators today so that we can do it a whole lot easier the next 6 times or so. Okay. You guys can do this on Desmos also. I'm just not completely sure how or where. So if you guys want to mess with it that way, you're more than welcome to. Okay. No. No. Okay, my little young cherubs. As we go through the notes, there's probably extra notes you need to be taking, marking down, highlighting, stuff like that, okay? All right, here we go. The idea of modeling. So they're going to call this modeling. We're going to cover 13 and 14. Hit me. It's one of those reminders. Modeling functions and applications. So anytime you see modeling, basically it's word problem type deals, okay? In that cabinet, Emma. One of those is stats and one of those is pre-cal. Probably the left one. I think that's pre-cal. Good? All right, so the idea of modeling, or also called regression, is a major component in AP pre-cal curriculum, and it's going to be revisited throughout the course. So like I mentioned, what we're going to do today is going to be revisited several times. So get familiar with it now, and that way it becomes a whole lot easier for you later. These topics will utilize the graphing calculators heavily. I mean heavily. Like, it's impossible to do these without a graphing calculator. Impossible. Okay? And it's also going to include context. What I mean by context is it's a word problem. And so word problem involves context. And in context, you just kind of use all of your answers, making sure we put units of measurement, talking about what it is in the context. The number of tennis balls hit, or the flight of the tennis ball, or whatever we're talking about, okay? So in Unit 1, we're going to work with regression models for polynomial functions. So Unit 1, which is the test that you're going to take next Wednesday, we're going to deal with polynomials. And that's what we did the entire chapter, right? We dealt with linear, very, very little, if any, because linear should be second nature to you guys by now. Quadratic, we did not deal a whole lot with. Cubic, we did not deal a whole lot with. Then we started doing quartic. We haven't done any quartics. But again, we're talking linear, quadratic, cubic, and then quartic looks very similar to quadratic, except it may just have another hump in there, right? And for rational functions, and we dealt with rationals the entire second portion, right? Starting with 1.7. So the rationals is kind of the big portion of it, because rationals are more new to you than the other functions, okay? So building a regression model on the graphing calculator requires 2 steps. One, you got to enter the data into your calculator. Well, duh, if you don't enter it in your calculator has no idea what to do with it, okay? So they're going to give you step-by-step on how to enter this stuff in your calculator. Everybody does use TIs, I'm guessing. Yes? Anybody not have TI? TI is the worst one to use, but that's what everybody has because they did a better job of marketing than anybody else. So you're going to hit my favorite button on this calculator, and it's the one that says STAT. That's my favorite button. Okay? All right, so let me explain to you what each one of these do. Edit. That means you got to put the data in there. Sort it ascending. I don't think you'll ever need to do that, but that's what that does. And then this sorts it descending. So if you ever just want to put it in order, it will do that for you. Again, I don't think you'll ever do it. Clear it if you need to remove the data out of a list. There's more than one way to do this, but that's one way. And then set up editor. And I'll emphasize set up editor because there are times where you'll need to set up editor, okay? So let me just show you that really quickly. Y'all just kind of watch. Typically, you should have L1, L2, L3, L4, L5, and L6. My guess is 99% of you do because you've never used this before. And if you never used it before, you wouldn't have any reason not to have L1, L2, L3, L4, L5, L6. I hardly ever use L3, L4, L5, L6. I typically use L1 and L2. And I typically always put X's in L1 and Y's in L2, but you can do it any way you want, okay? So here's what setup editor will do. Because we get in such a habit and we don't really know how to clear all that data, and I don't want these test scores in there. Those are not test scores, I'm just kidding. We go up here and we hit delete. Well, if you hit delete, L1's gone. Well, crap. If you went over here accidentally and you hit delete, now you got L3 gone, and it just, you can get them back if you go over here. You can either do it, you can do it whatever you want. So here's L1, it's blue, or it's the second. So there's L1, L2, L3, L4, L5, and L6. So that, I mean, that's good information to know also. So if instead I can need L1 over here, if I do second L1, well, it didn't delete them, it's still there, it's just gone, it's invisible. So that didn't, so right, so now I got it jacked up and it doesn't do 1, 2, 3. So if I ever just, if it's jacked up and you don't see something or something's gone, stat, setup editor. Just hit number 5 and hit enter and it'll say done. And that puts 1, 2, 3, 4, 5, 6 back in there just like it's supposed to be. So now if I do stat edit, you'll see 1, 2, 3, 4, 5, 6, okay? So sometimes whenever that's jacked up, just stat, you can do it at any time, and just, you're going to get, do yourself a favor instead of playing like Tetris up and down, just hit the number. It's a lot faster that way. So I'll just hit 5, okay? Instead of going down to 5, just do yourself a favor. And then you hit enter and it's done, okay? So you might use that, but then again, you may not ever use it, okay? Stat, if I want to clear a list, this is probably the easiest way. Of course, I told you not to play Tetris, and I just did, right? If you clear a list, but you have to tell it which one to clear. So you just hit second L1, and it will clear L1. And if you want to clear more of them, you can hit comma. Comma's right here above the 7. And I can clear L2, okay? And I can hit enter, and it's done. And then if you go to memory, second memory, you can clear all this. And so sometimes that's good because you kind of want to start fresh sometimes. So that clears them everything. So now if I do stat edit, I don't see anything. Okay? So everybody okay with that? Stat, get comfortable with that button, right? You come up to test, I forgot where to go. I'm going to forget where to tell you on test day. Any other time I'll tell you. So edit it is where we have to put in the data, sort it ascending, sort it descending, clear a list, and then set up editor, okay? If you go over here to calc, oops, sorry, go over to calc, 1 variable stats, 2 variable stats, you'll never ever use this. We're going to talk about this one, we'll 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 talk about this one, and then we won't talk about these until unit 2 or unit 3, actually unit 2. Okay with that? So linear regression if it's linear, quadratic regression if it's quadratic, cubic regression if it's cubic, and then quartic regression if it's quartic. And most of the time they're going to tell you. Most of the time they're going to tell you. And then there's another lin reg. So we'll talk about that in just a second. Camille?
What if it's like a quintet function?
There's a power functions down there. But we don't deal with those, right? But it does any type of regression. So this regression stuff, this REG, is what we're going to be basically teaching you today. And that's what we're going to do in Unit 2, and we're going to do it in Unit 3. And it's one of your free response questions on the AP exam. Okay, so it's definitely one of the free response questions on the AP exam. And then over here is tests, and you won't use any of this stuff. You won't use any of this stuff unless if you take another class, we use all of them. Yeah. Okay. So you quit, whatever, clear, yada, 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 yada. Okay. Sometimes I'll hit y equals, and you'll see that I got plot 1 on. We'll talk about that in a second. You typically don't want plot 1 on because I guarantee it, if I hit graph right now, it's going to give me an error. No matter what I do, it's going to give me an error because I'm trying to graph plot 1. Well, guess what? I don't have any data in there, right? Because I just cleared L1, 2, 3, 4, 5, and 6. So it's trying to graph plot 1, and I don't have anything in there. So it's giving me an error. And this is one of the most common things that students mess up on. Like, it won't graph. It'll graph. It's just trying to graph something you're telling it it can't. So sometimes I'll look at Y1, and I'll see plot 1's on, and I'll see an equation in there, and sometimes I'll clear those bad boys out of there too because I don't want anything. I'm starting fresh right now. And you can leave stuff in there or what, you know, you just got to start getting comfortable with what is going on. Notice that this is a 9. There is a 0 down the bottom, and sometimes it's crazy. You'll end up something in a 0. So you might see something else that might give you an error, right? So just recognize those type of things. If your plot's on and you don't want it on, there's 2 ways. You can go up and just enter toggles it on and off. So now it's off, I can turn it on. Enter toggles it on and off, okay? That's your plots. You can also hit second y equals, and those are your plots. And you can see that they're off. There's actually a plot 4, but we'll never use it. I just use 1. I don't ever want 2 on, and I don't ever, but you can do those, right? As you get more comfortable. Okay, so y equals, check that stuff sometimes. If you graph something, you get errors, it's because you're trying to graph something that you can't. Okay, all right, here we go. So stat edit, that's the first thing we'll talk about. All right, so there's your notes. Where's my notes? There they are. Stat, big red button, except it's not red, it's only red because you're hitting it. And then there's edit. Enter data in list with L1 equals X and L2 equals Y. Again, you don't have to do that. You can put L3 as your X's, or you can put L2 as your X's and L1 as your Y's. It's just, I think you want to remain consistent, okay? But if you switch all that stuff up, it's not going to be, you don't delete it and start over. You just have to do some different things when we go through the process, okay? So just kind of remember all that stuff. You get a bonus stuff because I don't believe, no, I'm not being cocky. There is nobody that knows this calculator better than me. It's just it's not cocky, it's a fact. It's a fact. They'll come down here and ask me, what am I doing? Step 2, in the stat menu, arrow to the right to the calc. I showed you this already, right? Select the desired regression model. Most of the time, they're going to tell you. There are 2 linear regression options, 4 and 8, okay? I don't care which one you use, but here we go. Let's go here, and let's go here, and let's hit refresh and reload. If you decide to take another class next year, they'll want you to use whichever one it is. I don't know what the numbers are. But one of them says AX plus B, which is what you guys are used to seeing because that's like MX plus B. Okay with that? That's what you guys are used to seeing. The other one says A plus BX. Okay? I don't care which one you use. You don't care which one you use. You're probably a little more comfortable with this one. Most of the time, we start using this one more. And I don't know why, but they just do. I don't care, but here's what you need to know. In this particular one, A is the slope. In this particular one, A is the y-intercept because the number in front of the x is the slope. And you already know all that stuff, but you guys get so ingrained mx plus b, and b is the y-intercept. Well, not in this one. B is the slope. So just understand that, okay? And so that's what they're trying to tell you right there. I don't care which one you use. What the heck? I don't care which one you use. Just understand that if somebody uses this one and somebody uses this one, you got different numbers. Okay? All right. Sorry, I got sidetracked. ADD. Ah! Where am I going now? See, I can't think. Oh, notes. Notes. Stupid phone calls. Okay. There are two linear regressions, linreg AX plus B and linreg A plus BX. So again, just recognize those two things. It's numbers 4 and numbers 8. You're probably more comfortable with 4 than you are 8. AP won't care which one you use. I don't care which one you use. Just recognize that which one you use depends on what the slope is and what the y-intercept is. Okay. These two options are essentially equivalent. Consider option 8 for AP stats. He actually tells you that. Use L1 for X list, use L2 for Y list. Again, you don't have to, but it's just my recommendation because you just want things to run consistent. And typically your X values are your inputs and your Y values are your outputs. And when you see it that way, it just streamlines everything, okay? L1 are in blue above 1 and L2 buttons. Oh, I told you where L1 and L2 and L3 and L4 and L5 and L6 are, okay? Tip, for store reg, we'll do that in just a second. I got to show you that as we do that as we go. Okay, all right, so here's example number 1. And notice the little calculator symbol, right? Anytime you see that calculator symbol, not only are you can use a calculator, you almost have to use a calculator. Like there's no other way to do this question if you do not use a calculator. Okay? So it says the age in weeks, and then I can see up here age in weeks, and they're using T and W. That's another common thing is they don't like to use X's and Y's. So they got T and then they got W sub T, or not sub T, but W of T, right? So there's the function, that's the Y, because it looks like a function. You got a big W and you got parentheses T, and you got T. Okay, just, yeah. We got the age in weeks and the weight in kilograms. And again, that's important to recognize what units we're in because they'll throw a little trick in there and switch those up sometimes. Give it to me in grams or something. They'll give you a conversion too. Of 5 randomly selected babies from a particular pediatrician's office, and they're listed in the table above. So here is the age of the baby and their weight. And it's 5 of them. So there's the age and there's the weight. Good enough? Again, kind of just soak all that stuff in of what they're giving me. A linear regression. Okay, linear regression, and then they put y is equal to a plus bx. They might say ax plus b. Again, they don't care. Can be used to model this data. So they're telling you that this is a linear data. Sometimes they do tell you, sometimes they don't. Most of the time they do, because they want everybody to have the same answer. Write the equation of the linear model for this data, for these data. I don't know what the plural is. This data. This data is singular. Whatever. Who cares? I don't teach English. So here you go. You're going to take that little calculator, and you're going to hit stat, and you're going to hit edit, and you're going to put the x values in L1, or in this particular case, the t values. And I recall it was a 4, and then I think it was a 5, but then I don't remember anything after that. 6, 8, 12. Okay, boom. If you put an extra one in, you can delete individuals. So if I messed up that 8, I can delete that 8. And if then now you don't have to put them in order. If I want to put the 8 here, that's okay. But just remember, if I put the 8 here, I got to put the number that lines up with the 8 here. Right? I don't want to put these out of order and these in order. Okay? So just understand that stuff. And if you mess up real bad, sometimes I don't even delete them. I just overwrite them. Right? But if there's extra ones, you can delete as you go. All right. Here we go. I'm done. I forgot what the weight. I don't have any idea what the weights are. 4.2? 4.2. Uh-oh. 4.2. 4.8. 4.4 and then 8. 5. 5.7. Okay, I do like to look at the data and notice that this is going up, maybe not consistently, but it's going up, and this is going up. That's good, because if this was going up and this went up and down, I'm not too sure it'd be linear, right? Just kind of recognize those type of things. But again, they told me that it's linear. So my data's in there, I'm good. That data is not going anywhere. You can go to any class you want, still work your calculator like you want to. It's there. It's there until you delete it. Somehow, it's there. And your calculator still works. Doesn't matter if it's in degrees or radians or whatever, okay? All right, now, we did that part of it. So, we enter the data into L1 and L2, select lin/reg. So now we're trying to find the equation because that's what's right, and the equation for the linear model. So they're telling you step by step on how to write the equation, okay? So, here's what I'm going to do now. I'm going to go to stat, and I'm going to go over to calculate, and then I'm going to find lin/reg. And why am I doing lin/reg? Because it told me it was linear. Now, be careful. ln/reg is not lin/reg. That's the natural log. So the one that says lin/reg, and again, I don't care if you use 8 or if you use 4. Okay? If I use 4, it's going to give me an A value and it's going to give me a B value. If I use 8, it's going to give me an A value and a B value. It's just where you guys have to be intelligent to recognize that if I do this one, A is the intercept. I'm sorry, yes, A is the intercept, B is the slope. And then this one, A is the slope and B is the intercept. So they don't care. They told me to use 8. X list L1, Y list L2. That's a default. So that's why I tell you, if you use your X's for L1s and L2s, it just streamlines and makes things easier. If you didn't use L1 and L2, this is where you would have to change that. Okay? Frequency list. That asks you basically how many times do these occur. I just always leave that blank. I just leave that a blank. Store it. You really want to store this, because if you don't store it, here's what's going to happen is you're going to have to write those numbers down on your paper. And then you're going to have to write the equation down in your Y1. You'll follow what I'm saying, right? You're going to have to write that equation down in Y1. Well, you're never going to write down all the numbers, and AP Pre-Cal will ding you if you're not exactly precise on those 3 numbers. So you want to store that. Here's the easiest way to store it. Some of you can't do this. You have the older 84s. I think I saw one. Is there an older 84 in here? That Barry has one. So it's okay. You still do it. It won't. You can't do it. Maybe you can. I don't. You can tell me. Alpha. I forget, but it doesn't matter. You can get there. So I think it's trace. It didn't go. Yes, there's Y1. And if you forget it's trace, you can just go back and forth. Oh, here not. It didn't go either. Come on, wait. There it goes. So there's other stuff. Okay? But it tells you down here, even on the bottom, that's Y1, here's Y2, here's Y3, here's Y4. I'm sorry. Y equals window, zoom, trace. So whatever. You're going to hit trace. If you don't do trace, does yours do that, Miss Berry? Does yours do alpha trace? Oh, okay, cool. Then we're good. So Y1. So now it's going to store this equation in Y1 for me. So I don't have to do anything to write it all down or remember it or anything else, right? And then you're just going down to calculate. Boom. Oh, wow, that's nice. A is fairly a small number. B is a fairly small number, meaning small. It doesn't go out to a whole lot of decimals. Okay? We always want how many decimals in this class? All of them, at least 3. I like to tell you 4, because if you put 4, you're not going to miss it. If you put 2, you're going to miss it. The only time you're not going to miss it if you put 2 is if that terminates at 2. And I don't think anything will terminate at 2 in this class. So you will miss it in this class if you only put 2 decimals. If you put 3 or 4 or 5, you won't. And they don't care if you round that third one or not. So if this is a 5 and you don't round it up, they don't care. But if you don't put it the third one, they will care. All right, so we're done. Now, in this particular one, here's my A value, that's my y-intercept. Here's my B value, that's my slope. If you chose the other one, it's still going to give you A and B. You just got to recognize which one A is and which one B is. Everybody okay with all that stuff? Good? Okay, so we got to write that equation down. So you got to remember that, or you got it on paper. You got it on a calculator, so you don't have to, at least, I got to try to remember it. I'm not going to remember it because you guys are going to tell me. So there's the linear regression model. I don't like that they put y equals because my y values are w sub t, right? So I think that would be a little bit better than y equals. Sorry, I keep saying sub. W of t is equal to, and r squared and r. We got to do that in a second too. 3.545, and in this particular one, that's the intercept, plus 0.185. I'm going to put t because they use t's, and y'all okay? Good. Again, you want, will they count me wrong? I don't know. If I use t, they won't count me wrong. Y'all fair? If I use x, I don't know if they will or not, but I know they won't if I use a t, so I'm just going to go ahead and use a t. Using the linear model from part A. So, part A. Now, this is where you guys need to also understand, if you get this wrong or your calculator dies, you can't find this equation. Use it, predict it when they're 10 weeks old. Make up an equation. You're not going to get it right anyway. Make it up. Plug in 10. They'll give you the points for this one. Because you know what you're doing. You just didn't know what you're doing here. They don't double ding you. Y'all follow what I'm saying? Double ding. If you miss this, you're going to miss this. But if you show everything and you do it correctly, they'll give you the credit for this because you know what you're doing. So when it's 10 weeks old, that's in my x values or that's my t values. So I need to plug that in for t. Here is the easiest way. The easiest way. You don't have to do a whole lot. Again, all this stuff's in there. All this stuff is in there. We stored it in y1. That's why we wanted it in y1. If you didn't put it in y1, you got to plug in everything. So now here's what I'm going to go back. I'm going to go back to, oh gosh. I did not want to do that. That makes me very angry. I got to do it again. Sorry. Alpha, trace, enter. It's good practice for me. Okay. Yay. Alpha, trace, y1, parentheses, 10. Was it 10? That's what they want plugged in, right? That looks like f of x, right? That's what it is. That's going to plug in 10 for me, and boy, it sure makes it a whole lot easier to do it that way than for you to plug in and hit every one of those little dots and hit a little parentheses or times and hit enter. Because guys, time is an issue. Time is an issue, and you don't want to waste a whole lot of time doing stuff of hunt and pecking. I mean, the test is hard enough as it is. You don't want to make it harder. So the weight is 5.395. There's my 3 decimals. 5.395 grams, kilograms? Kilograms? Isn't kilograms like really heavy? Huh? Is it not? It shows you how much I know. Oh, it's okay. I'm going to answer the question. Just seems kilograms? No. Whatever. Okay? Y'all good? The weight of the 6th baby is 5.3 kilograms using the model what age? All right, so this is how I'm going to show you how to do this one. There are 2 ways to do it. This first way is the easy way for me with your calculator. So they're telling you that y is 5.3. Y'all with me? And then you got it equals to, I forgot these numbers. Whatever, right? Whatever plus whatever x. Y'all good? Okay. I move the 5.3 to the other side because that's not a real hard thing to do. So if I move the 5.3 to the other side, it's just going to be minus 5.3. And now it equals 0. And so I'm even going to cheat a little bit more, and I'm not even going to subtract. I'm going to go to my y equals. This will help you out, I think, more later chapters than this one. Okay? Y equals, and I'm going to go to the end of this thing, and I'm just going to put minus 5.3. Okay? Enter. And then I'm going to graph this thing, and I got to basically find the x-intercept. I got to find the x-intercept. Okay? The other way that you can do this, if you don't like this, is to put 5.3 here. And then you'll have two lines. You'll have a linear line and you'll have a horizontal line, and you have to find the intersection. Okay with that? This was not bad because it's 5.3. When it's like 280 something, it's worse because you got to change your windows around a whole lot. And that's why I just like to subtract it here, and I always just look for the x-intercept. Okay? Do it either way. It works just fine. Hip, you got something?
If you use 5.3 equals the equation and then subtract 5.3 into the equation, isn't that your intercept value?
Yes. Yeah, and you could do it manually also because it's linear, right? But I got my calculator. I don't want to do anything manually if I don't have to. Graph it. Oh, there's me. I got mine jacked up, right? That's going to happen. Zoom 6. Zoom in, out, 6, standard. That does the 10, 10, 10, 10. Zoom 6. Oh, I don't know if I quite see the x-intercept. I think I do, but I'm not too sure. If you're not too sure, go to Window and just add a couple of numbers to that x value. Maybe make it 12. Y'all okay? I gotta see it. I gotta see it. You gotta be able to see it on the graph. If you don't see it on the graph, you gotta move your windows around to where you know for a fact you see it. Okay? And so that's where you can change your window around. You can change that window to do anything you want. In fact, I might even change this to 0 because I know there's going to be no baby below 0. Right? I could probably even change the y minimum to be 0, except I don't want 0 because that just puts it right on it. Y'all with me? So I might do like -1 because there's no babies below that. But I still want to see that intercept. So as long as you see it, they don't care. And now I'm going to do second. Calculate. And you're going to do one of two things. If you drew them on separate lines, you got to find the intersection. If you don't want the intersection, I just need the 0. And the 0 is easier than the intersection to me. So if I just do 0, it's going to ask you for the left bound. That means you got to put this stupid little blinky thing to the left side of that 0. It's already to the left side of that 0. So I'm just going to hit enter. They don't care where, as long as it's to the left side. And they put you a nice little boundary. Now it wants the right side. Again, save yourself Tetris. Just punch in a number. Excuse me. What did I put out there? 12. So I'm going to punch in 11. But you can punch in 12 if you want to. Just punch it in. And it will automatically go there as opposed to you playing Tetris. And again, how far? It don't matter. As long as you capture that 0, that's all they care about. And now it says guess, and I don't have to guess. It's just going, boom, it's going to give it to me. And there's the x value, the 9.486. And if you want to put the 4, put the 4. And if you want to put the 8, put the 8. And if you want to put the 6, put the 6. But you have to put the 486. And if that 4 was a 5, you can still put 486. And if you want to put 487, you can. Yep.
Let me just do, so 5.3 equals the model.
Yep.
Subtract 3.5.
Yep. Yep. Yeah, you can do, like I said, you can do that algebraically also. This one, because it's linear. Y'all with me, right? It doesn't take a whole lot to solve that. It doesn't take a whole lot to solve that. You for sure don't want to do it when it becomes natural logs or trigonomic functions. You do not want to do those manually. You want to use a calculator. If it was quadratic, I'm not too sure I want to do it manually because it probably doesn't. Linear, you're okay. Y'all get your catch on. Talk to me, Em. Again, when it asked me for them, so when I go to second calc, zero, okay, left bound, I just have that cursor's got to be to the left side of that zero. Okay, so you found the intersection, right? So you did the, great, I meant to cover this. I'm glad you asked that, right? So if it says first curve, you found the intersection, it tells you up here you're probably at Y1. So you just hit enter. And then second curve, it tells you Y2, provided those are the only ones you have in there. So let me just do that for you real quick. I want to make sure I show you that. Delete, 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 delete. 5.3. Right? Graph. There. I got to be able to see that intersection. And if you don't see the intersection, you got to mess with the window until you do see it. And then if you want to do second calc intersection, 5, it says first curve, and it says Y1. So that's what I want as my first curve. And it doesn't matter which one's your first curve. And then it says second curve, Y2. Okay, good. Guess. I don't have to guess. There's only one intersection. So it tells me in that same value. Okay? And again, this one's a whole lot easier because it's linear and because I can see it. Because I can see it. And it might be easier for you to do first curve, second curve as opposed to left bound, right bound. I don't know. Okay. Here, boom. Oops, sorry. Now, let's talk about this. Selecting an appropriate model. While some problems will indicate which model you should use, you will also be expected to select an appropriate model. I mentioned this. Given tables, values on the context. So linear, basically it's a constant rate. Quadratic, roughly linear rates of change. Holy cow, we're going back to earlier stuff. Or roughly symmetric with a single max or a single min. In other words, you see that data kind of going up and then it goes down, or vice versa. It's going down and then it goes up. Now, a little bit that still might be linear because it might be linear with just a little dip in it or something, but just kind of good. And then cubic, basically if it involves volume. I look at the context of the question, right? As a baby is born and they're growing, they're typically growing at a linear growth. And then at some point it levels off, right? It doesn't stay consistent. That really hurt. So typically, I just kind of look in the context of the question, right? If I'm throwing a ball up in the air, it's probably coming down at a quadratic type shape, okay? If I'm looking for area, I'm probably quadratic because area is length times width. If I'm looking for volume, I'm looking for cubic because it's 3, length times width times height. So I kind of look at the context of the question also to decide on which model should follow it. Okay? Everybody good? Most of the time they're going to tell you. Oh, here, for each of the following situations, determine whether linear, quadratic, or cubic should be appropriate. So here I have balloons. They're being filled with water in preparation for an epic water balloon battle. Each water balloon is roughly spherical. Sphere. The radius of each water balloon is measured relative to the amount of water it holds. So the amount of water it holds is what type of word? Volume, yes? Which is typically cubes. So that's probably going to be a cubic model. Okay with that? Okay, good enough. Good enough. Totito's pizzas are on sale at the local grocery store. The price of one pizza is between $1.99 and $2. Good gracious, where are we getting that pizza at? Depending on the variety, the total number of pizzas are relative to the total price. So as the pizzas go up, the price goes up linearly. I don't think it's going to be anything else. So linear, line, or I don't know, price goes up. I'm sorry, number of pizzas. How about that? Number of pizza goes up. Price goes up. Beautiful. I don't like to always do, I don't like naked answers, right? We like to have something explained in it just to make sure that, hey, you're telling the grader, this happens, this has to happen, and if it doesn't happen, I'm just wrong because everybody's going to be wrong. A sprinkler is placed in the yard to water the grass. The sprinkler rotates in a circular pattern and water all the grass between the sprinkler head and the furthest distance it reaches. The radius of the circular path is measured relative to the area, probably quadratic. I don't know why we got so much room to write that, but good. And if you don't know how to spell something, somewhere up there, they're going to ask you, decide if it's linear, quadratic, cubic, and so you can look up there and cheat. But they don't take off for spelling either. The table above provides data for 8 ordered pairs X's and Y's. Which function best models this data? Linear, quadratic, or cubic? Explain your reasoning. And then they want me to write the equation. So I'm going to cheat and put that data in there. I'm going to cheat and put that data in there, and here we go. Because I got to write the equation anyway. So y equals clear, second list. I want to clear them all. So it'd probably be easier to hit second plus and clear all lists. 4. Good. And if you really want to go back to normal, you would hit zoom 6. And that'd do a 10, 10, 10, 10. But you don't have to do that, because I'm going to have to change my window anyway. Stat edit. Beautiful. X is going L1. If by some crazy chance you lost it or did something else, set up your editor. Okay? Somebody help me out with these numbers. Oh, that's an easy one. 0.4. 0.9. 0.2. 1.7. 2.2. Gee, Benny, crisp. How many we got? 3, 4. Notice down here it does say like this is L1 of 9. That will help you to make sure you got the right, like you should know that you have 8 data points. Okay? And now, again, where students might mess up is we don't put these in order. They got to line up. They got to line up. If they don't line up, you're not going to get the right answer. Okay, hit me.
5, 10.6, 15.4, 17.1, 18, 16.5, 10.2, 2.8.
Beautiful. That is in there. Okay? You're getting bonus coverage here. Goes up, goes down, probably quadratic. This is what I do. I cheat. I like cheating. Second, y equals. Turn my plot on. So enter plot 1. There's plot 2, plot 3. I don't deal with 2s and 3s. I only deal with 1s. On. Type. Scatter plot. Time series plot. Histogram. box and whisker, whatever. I want a scatter plot. X is L1, Y is L2. Whatever you want to look like, whatever dots you want it to look like. Beautiful. When I hit graph, I'm probably not going to see all of it because my window's jacked up. So hit zoom 9. What does it look like? I almost don't have to guess. Like, that's pretty obvious it's quadratic. I could see it from the data, but now I can see it with the points. So let me do that again. That Fastwater doesn't do this. Second y equals, turn the plot on. Now this is going to mess you up if you don't have data in there and you try to graph it. Remember that, right? Because now if I hit y equals, look, plot 1's on. Okay? So just, it's okay if you got the data in there, but if you don't have data in there, it's going to mess you up. Go here to stat, calc, right? And we decided it's quadratic, quad 5. Boom. L1, L2, frequency, store it. Always store it. Just out of habit, just store it. Alpha, trace, and I put it in Y1 because that's all I care about. Staying consistent. Calculate. Boom. There's A, which is the number in front of x squared. There's your B, which is the number in front of x. And there's C, which is the number in front of, or the constant. Okay? Make sure you take it out 3 decimal places. Notice that A is negative. Well, duh, that thing looked like this. It better be negative. It's got a max. Bless. Okay? There's 15. There's 4.995. If you want to put 4.995, I think that's what I would put. Actually, I would probably put 4.9956 because that's one of those weird ones that if you put 5, yeah, they would give you credit. But I don't like it. I like my decimals. So I would probably put 4.9956 just to be safe. Put 4 or 5 to be safe always. If you put 3, you're good. Put 2, you're not. So I just always put 4. And then I don't have to worry about rounding or doing anything. Just put them. Doesn't take that much to write one more number. So no, I want to get it right. Beautiful. Everybody happy, happy, joy, joy. Which model? So quadratic, explain your reasoning. The y values increase at a constant rate or something like that. Is that what we said about the average rate of change? They increase and then they decrease. Write an equation. So there's my equation where I'm going to write that. I'm going to put y equals because I got a y right here. Okay. I can find the max, I can find the intercepts, I can find all kinds of things with that data using my calculator. Okay? All right. How are we doing? Not too bad. This is bonus coverage. We're going to talk about this now because, again, time starts getting to be a crunch later. And so we're going to talk about residuals. Okay? We're going to talk about residuals. When we use a model to predict values, listen to what this says, we expect our model to produce values reasonably close to the actual values, right? Let's go back real quick. Look what I'm going to do. Now what happens when I hit graph? Look at there. Man, I got really, really close. Like I hit darn near every point. Like I think I did hit every point. Good? I mean, sometimes we miss them just a little bit. Right? Because the line may not fit them perfectly. Sometimes we get close, but we just don't hit them perfectly. Let's go back, okay? So, reasonably close to the actual values, but our models are not expected to result in exact, generally. The difference between the actual value and the predicted value, the predicted is the one that comes from the line, right? I'm using the line, y equals whatever. When I plug in the number for y, that's the predicted value. The actual value is coming from the table. Y'all with me? The difference between the actual and the predicted is called a residual. What's the name of this class? AP Pre-Cal? difference between the actual and the predicted. Don't flip-flop it. Don't do the predicted minus the actual. It's actual minus the predicted. Actual minus the predicted, okay? And what that means is, basically, here's my line. If the actual point is below that line, listen to what I'm doing. I'm over-predicting that value. It's a positive number. If that actual point is above it, then I'm under-predicting that value. Good enough with all that? You guys are getting bonus coverage. So that's why you have to do A minus P. If you don't do A minus P, you're not going to get the positive and the negative. And I say that is you don't have to do A minus P, but you have to know if you're under or over the line. If you're over the line, if the actual point is over the line, you're under predicting. If the actual point is under it, that means I'm over predicting. Okay? So, here we have time or age in weeks. Here we have our weight. All right? Should have left that stuff in my calculator, but that's okay. Using the model from example 1, what is the residual of a baby that's 5 weeks old? So they're asking you to do these things. So because I took everything out, I'm not going to do everything else. The actual value comes from the table, okay? 5 weeks old. Which one was 5? Is that the second one? 4.4 kg. The residual is the actual minus the predicted. So I'm going to put A minus P, and the A is 4.4. And then the P, you got to go back to your equation, which we all deleted, and we got to do the second Y1, or I'm sorry, the trace Y1 and put in 4.4 to predict it from the line. Okay? And so you're going to get that value. Let's do W sub 4 sub 4. Y'all good? Hit me.
Is that when we go to like do the calculations of the equation? Will the equation still have the like minus 5.3 on the end?
Oh, no. Without the 5.3. Yeah. Y'all, good question. Y'all hear what she said, right? With that 5.3 that we put in there, because that's when we wanted to see it. Well, that's not part of the equation, so make sure that that's not in there. Good. And then the interpretation. Well, my interpretation is the value positive or if it's negative. So if that value is positive, then I am over predicting the weight of that baby. We got to be in as much context as we can. If it's a negative value, that means we are under predicting that weight of that baby. Good enough with all that? That's bonus coverage, because we're going to talk about those residuals, and that's it, right? We're done. That said, that wraps up this chapter, this unit 1. Okay? Now, I'm going to give you today 1.13, 14 homework. Okay, that's 13 and 14 homework. I'm going to give you a bunch of other stuff that starts reviewing, because you guys, I don't see you again till Monday. Actually, our test is next Wednesday. It probably doesn't hurt you to start doing some kind of reviewing now. And I kind of like to review backwards. The most recent stuff first, because it's the freshest on my mind. And as you go backwards, but sometimes it's kind of hard to go backwards because you got to know this one and know this one. But if you know it here, then you don't. It's easier to review backwards. That's just the way I do it. Now, you guys, I don't care how you do it. Some of you guys don't need to review. Some of you guys can review all day and still fail. It's just life happens, right? It is what it is. I still love you. It doesn't mean anything about you. Okay, so just kind of recognize it, but I'm going to give you all that stuff now because, again, Monday we're going to do a couple things in class. And so review-wise that are going to be beneficial to you on the exam. So, but I want to do it as a class. I don't want to do it as individuals. So I've got a couple of things for you on Monday, but I'm just going to give you everything else that you could possibly need now because, again, I don't see you